A synchronous motor is a type of AC motor. To demonstrate the concept of a synchronous motor, this is the simplest example I could come up with. It is a two-phase synchronous motor, as was the first synchronous motor invented by Nikola Tesla. Tesla's patent was granted on May 1st, 1888. He referred to his invention as an electromagnetic motor. I have always found it difficult to decipher figures in patents, so I have highlighted his coil connections. The two vertical coils are connected in series, and the two horizontal coils are connected in series. By applying two sinusoids shifted in phase by 90 degrees to the two sets of coils, Tesla produced a rotating magnetic field that rotated his rotor. The four coils comprise the stator or stationary part of our motor. The two vertical coils are connected below the compass, as are the two horizontal coils. Here we see how the horizontal coils are connected and how the vertical coils are connected. A sinusoid is fed to the horizontal coils, and a sinusoid that is shifted by 90 degrees is fed to the vertical coils. This results in a rotating magnetic field of constant amplitude inside the coils. The rotor in a synchronous motor is a magnet or electromagnet. In our motor, the compass needle functions as the rotor. The compass needle rotates in sync with the rotating magnetic field. Hence, the rotational frequency of the compass needle will be the same as that of the AC sinusoid applied to the stator coils. I have an analog Discovery 2 which has two waveform generators. It is connected to and controlled by my MacBook. Shown on the screen are the outputs from the two waveform generators, two sinusoids that are shifted in phase by 90 degrees. One sinusoid will be sent to the vertical coils and the other sinusoid to the horizontal coils. The period of each sinusoid is 1 second. So our compass needle will rotate at a frequency of 1 hertz. Let's look at how I made the coils. I'm going to wind my coils from this 18 gauge magnet wire. I've used some packing tape to attach the wire to this PVC tube that I will use to wind the coil. I've completed 50 turns. So I'll remove the tape and pull the coil off the PVC. And I will use these little wires here to hold it together. So I have half my coil wound. I've taped the wire back to the PVC tube, and now I'll wind the other half of the coil. I have 50 more turns. Now I will remove the tape and slide the coil off the PVC. And again, use these wires to hold the coil together. I've completed the first coil, and there's 50 turns on each side. I have my 2 coils wound. Now, magnet wire has an enamel insulation on it, which I'll have to remove from the ends to make electrical contact. I'll just use a knife to scrape the enamel off the ends. You should be able to see the change in color where I've removed the insulator. The 4 coils comprise the stator or stationary part of our motor. Let's look at how our system of coils and our 2 sinusoids produce a rotating magnetic field. The sinusoid we're applying to the horizontal coils is 90 degrees or pi over 2 radians out of phase with the signal we're applying to the vertical coils. The top trace is the signal applied to the vertical coils. The bottom trace is the signal applied to the horizontal coils. At T equals 0, we have maximum current going through the vertical coils and 0 current going through the horizontal coils. So only the vertical coils will be producing a magnetic field. At T equal to 0, the magnetic field is only pointing in the vertical direction, and that will be the direction the compass needle points. I have marked off 1/8 cycle increments. Let's look at the first 1/8 cycle increment. The current to the vertical coils has decreased and the current to the horizontal coils has increased, and they will be of the same magnitude. We will have equal components of the magnetic field in the horizontal and vertical directions. The sum of those 2 vector components to the magnetic field will mean we will now have an overall magnetic field that has rotated by 45 degrees, and our compass needle will also rotate in that direction by 45 degrees. Moving another 1/8 cycle, we see that the current to the vertical coils has fallen to 0, so there will be no magnetic field in the vertical direction. The current to the horizontal coils has risen to a maximum, and we'll have the maximum magnetic field in the horizontal direction. The magnetic field and the compass needle will have rotated another 45 degrees so that they will be in the horizontal direction. Let's do one more 1/8 cycle increment. Now the current flowing to the vertical coils has reverse direction, so the magnetic field in the vertical direction will now be pointing downwards, and the current in the horizontal coils has decreased, so our horizontal component to the magnetic field will have decreased. The sum of those two components will mean the magnetic field has rotated another 45 degrees in the clockwise direction. And our compass needle is going to follow that magnetic field. This is how our coil arrangement and two sinusoids results in a constant amplitude magnetic field rotating in the clockwise direction.